water flow log. This video shows the workflow to incorporate water flow log stations in multi-phase production logging interpretations. Water flow logs are pulsed neutron measurements based on the oxygen activation principle. In a water hydrocarbon environment, water is the only source of moving oxygen. A burst of neutrons activates the oxygen, resulting in an excited state. The oxygen returns to a normal energy level by giving off gamma rays. As the PNL tool contains a multiple gamma ray detector, it is possible to estimate the water velocity by identifying the time to the peaks and the distance between the source and detector. In this example, the apparent velocity of a spinner and water holdup from electrical probes are already defined as input channels of the interpretation. To incorporate water flow log stations, go to Interpretation and Reference Channels. Click on Water Velocity. For flow profiling purposes, oxygen activation is recorded as stationary measurements. Click on Merge Search in Stations. Select all the relevant stations. When using any type of stationary measurement, the rate calculation zones are interactively defined, including the stations. Click on Rates and select a multi-phase flow correlation. While rate calculation zones include water flow log stations, all three variables are adjusted simultaneously to compute the rates. Proceed with OK. A simulated water velocity log is displayed in the water velocity track. Since this is a two-phase interpretation and there is redundancy in the measurements, the simulated apparent and water velocity do not perfectly match the measurements. This is to be expected, as the tools have very different principles and limitations. In this case, the flow is stratified up to the top perforation, as seen in the image view. Below this depth, the confidence on the water flow log is higher than the spinner. From the Rates dialog, increase the weight on the water flow log stations in the zones with stratified flow. This favors this measurement over the apparent velocity in the error minimization process. Click on Improve All and leave with OK. Naturally, the error in the match of the apparent velocity is higher than before in the stratified interval, but this is acceptable since the spinner is immersed in the water and does not measure a mixture velocity. The water flow is sensitive to flow inside and outside the casing and can be used for detecting channels and leaks. In this example, the station in blue is located below the deepest perforation, where the spinner velocity indicates no fluid movement, but the water flow log shows upwards water migration in agreement with the temperature. As the cross-sectional area of the channel is not known, it would not be accurate to use the water flow log to calculate the flow profile, as shown previously. The gamma ray of the near detector for all stations is shown. Due to the presence of the pipe, the gamma ray is attenuated when the flow is behind casing. This concludes this video about water flow log in EMERAUDE.